right? Okay, we are going for the addition of binary numbers. Let's suppose for a while that I have a number, an 8-bit number. This is 8-bit. Okay, according to the rule, if we have in a series, if you have any one in the series, you need to write one under it. One and anyone should be one, anyone should be one, 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 one. And we have, if we have two ones, so what we have to do in sum, we are going to add, we are going to write 0 and carrying a 1, which is obviously going to drop from the series, but this will have a little impact, which is obviously going outside the actual number, will have a different impact. Okay, how to prove that this addition is correct or not? Let's start it with a smaller number again, probably 1, 0, 1, 0, which is basically 1, 2, 4, 8 if we are going to write. So this is 5, equivalent to 5. And let me have another one, which is 1, 0, 1, 0, which is equivalent to 8 plus 2 is 10. So the answer should be 15. Adding the numbers. Should I write 1 over here? 1, 1, and 1. So you know that if we have 1, 2, 4, 8, 8 plus 4 is 12, and 3 is 15. So this is quite, it is proved, right?
Yeah.
So if I might calculate what the denary number of this one and this one and this one, they have the addition effect, but as this particular number is going outside the range of 8-bit, so adding all the numbers together don't have the accurate answer, for which we have to, add this particular, the 9th-bit number as well into our series to have the actual actual result, to see the accurate result, right? This is what we have to do. If the overflow, this is known as overflow. If the overflow is occurred, there are like two ways. One is to ignore it, simple. The other one is to add more binary digits to have a greater binary system computer bus for the accurate answers. So this can be, done quite easily, but whenever you are going to add the numbers, again, examination point of view, if you are adding the number and if it is going outside the range, you should show one, first of all, you have to show your carry. These are the carries. This is the sum. And if you are doing it, so you need to drop this number and somewhat do it like this. So it's outside the range. So you need to show your overflow as well, right? This the showing of carry and sum have one marks. Obviously, if you are adding it quite effectively, if it is wrong, so obviously you will lose some marks. But showing of carry and overflow might have 1 mark on it as well, right? We'll obviously practice this particular one later on. Mm, we do have like simple practices on it. Multiple practices are there with the overflow error and how to rectify the overflow error. Obviously, we need to add more bits into the system. So we'll have the impact of it. And we are obviously using the 8-bit pattern right now. We can have the 16-bit and the 32-bit and the 64-bit as well in our computing. So and the 128-bit as well. So we can have like a huge number set once we are either adding or subtracting a thing. That's why we don't have the overflow, usual overflow in computing. But obviously, we are doing it from like for the practices, we might have a little issue, and probably like in 8 bits we have issues. Okay, so now we're going to stop it from over here. And if you have any question, confusion, please do let me know right now. Otherwise, you can send me a message as well.
Okay, sir.
Right? Any question?
No, sir.
All right. I'll send you the few practice questions. Need to try it. So you'll have obviously a greater practice before any new exam is done, right?
Yeah.
All right. Okay. Bye bye.
Yes, sir. Thank you.
Okay. Thank you.